An uncrewed U.S. spacecraft might soft land on the moon this week, the first since Apollo 17 in 1972. If it succeeds in its landing, currently scheduled for February 22nd, Intuitive Machines' Nova C lander will be the first private spacecraft to ever soft land on the moon. Currently, only 5 countries have ever done it: the US, former Soviet Union, China, India, and Japan. It will also be the first US spacecraft to soft land on the moon since the end of the Apollo program. Let's dive into everything you need to know about this uncrewed spacecraft and this mission. Intuitive Machines' Nova C lander for this mission is called Odysseus, nicknamed Odie. The spacecraft successfully launched from Launch Complex 39A from Kennedy Space Center, Florida on February 15th at 1:05 a.m. Eastern Time. SpaceX confirmed successful deployment of Odie after launch. The lander is currently on schedule and the spacecraft is healthy. The team needs to perform a few maneuvers to position Odie for lunar orbit insertion, and on February 16th, they successfully fired the liquid methane and liquid oxygen engine, better known as methalox. That's the first time a methalox engine has ever been successfully fired in space. More on why that's a big deal a little later. They also performed a main engine burn as well as a throttling maneuver, which is something they'll need to do to land on the moon. That means they've successfully commissioned Odie's engine. The IM-1 mission is part of NASA's CLPS, or Commercial Lunar Payload Services program. This is basically NASA paying private companies to deliver payloads to the moon's surface as part of the Artemis program, and that is NASA's program to return humans to the moon's surface sometime this decade. A big part of the Artemis program is creating a sustainable and long-term human presence on and in orbit of the moon. Thanks to experience with the ISS, NASA has learned that incentivizing private companies to develop the tech to make this happen is better than just doing it in-house. Just look at the absolute boondoggle that is SLS, NASA's moon rocket. That's going to end up costing around $4.1 billion per launch. There's already been one lunar lander launched as part of NASA's CLPS program, Astrobotic's Peregrine lander. Unfortunately, that mission did end in failure. For more information, check out my video. A propellant leak meant that the spacecraft didn't even make it to lunar orbit, much less attempt a landing, and the spacecraft ended up burning up in Earth's atmosphere. Landing on the moon is not easy, so it's by no means a foregone conclusion that Intuitive Machines will succeed here. But it's a good sign that the engine is working properly and the spacecraft seems to be in good shape so far. The landing is currently scheduled for February 22nd later in the day. And honestly, if they soft land successfully, that's the win. That is the successful mission. Intuitive Machines did provide a detailed rundown of their mission success criteria, which includes 16 different milestones they have to achieve. At the time I'm filming this, they're right here at trajectory correction maneuvers 1, 2, and 3. What's going to happen is that the spacecraft will perform 3 burns to correct its trajectory. The expectation is that each will get Odie closer to where it needs to be, and therefore each subsequent burn will be smaller than the one before it. The team will then perform the largest maneuver, which will put the spacecraft into low lunar orbit around the moon. Numbers 9 through 16 on this list will happen pretty quickly. Number 9, descent orbit insertion, will happen on the far side of the moon. The lander will drop from about 100 kilometers above the surface to 10 kilometers. It will then coast for about an hour before powered descent. It's worth noting that after descent orbit insertion, the spacecraft will be fully autonomous and will run through steps 10 through 16 without any further input from mission control. If you've ever watched the live stream of one of these lunar lander missions, you know that this is where everyone, including those working the mission, are biting their nails. The spacecraft is designed to land at a velocity of 1 meter per second, and it'll take about 15 seconds after the vehicle touches down for confirmation that everything went well, assuming, of course, everything goes well. Those 15 seconds are going to feel so long. I have to shout out Intuitive Machines' great press kit for all this information, by the way. Some companies are not good about providing information, but theirs is awesome. I'll link it below in case you want to look through it. Let's talk about landing. Odie's landing site is the Malapert A crater about 300 kilometers away from the lunar South Pole. This is very close to one of the proposed landing sites for Artemis 3, Malapert Massif. It is important to note that because the moon is shrinking, yes, the moon is shrinking, the lunar South Pole is subject to some geological instability. We're talking landslides, moonquakes. If you want to know more, watch my video on the specifics of how that might affect NASA's upcoming crewed Artemis missions. If they achieve landing on the currently scheduled date of February 22nd, they will have about a week of lunar day to get some stuff done. A day on the moon lasts about 2 weeks, and lunar night is also about 2 weeks. Remember, one rotation of the moon is 28 Earth days long. This spacecraft is not designed to survive the harsh lunar nights, which can get as cold as -200 degrees Fahrenheit. That means that they will have about 1 week to perform all the science for this mission. There are 6 different NASA experiments aboard the lander, so there's a lot of science to do in that week. They are Lunar Node 1 Navigation Demonstrator, which focuses on autonomous navigation for future landers. Laser Retroreflector Array, which is a permanent location marker on the moon that will allow precise measurement of the distance of a spacecraft in orbit or on the surface to this array. Navigation Doppler LiDAR for precise velocity and range sensing. That's a LiDAR-based system that will measure altitude, direction, and speed during descent and landing. Radio Frequency Mass Gauge, which is a new way to measure fuel in low gravity. And then there's radio wave observations at the lunar surface of the photoelectron sheath. That will use radio frequencies to determine how human activity interferes with conducting science on the moon. And finally, stereo cameras for lunar plume surface studies, which is 4 cameras that will observe how the moon's surface is affected by descent and landing. It's a lot of science to do in a week, and what both Intuitive Machines and NASA learn from this will help us with further moon missions. Previously, I referred to Odysseus' engine as the first liquid methane and liquid oxygen or methalox engine successfully fired in space. That's a big deal. Here's why. Methalox is kind of the next-gen fuel that the space industry has been moving towards for a very long time. The Saturn V rocket, which took Apollo astronauts to the moon, used kerosene and liquid oxygen as propellant in its first stage. That's also what the current workhorse rocket of the space industry, SpaceX's Falcon 9 rocket, uses. There are a lot of advantages to using RP-1, which is rocket-grade kerosene. It's inexpensive and it performs well. But SpaceX's interplanetary spacecraft and rocket, Starship, will also use liquid methane and liquid oxygen as propellant. And there are a few reasons for this. It's more efficient, which is very important for rockets. When you're launching something from the ground, you are basically dragging it upwards into space. That means you are looking to shed weight wherever you can. Fuel is the heaviest thing you're taking with you. This is why rockets often have stages. The first stage is just to get you off the ground, and when you burn off all the fuel in it, it's jettisoned, so you don't have to continue dragging that dead weight up into orbit and beyond. Methalox means you need less fuel to get where you're going. It's also more environmentally friendly than burning kerosene. It's cheaper. It's more sustainable. If the idea is to get to the moon or Mars and eventually establish some sort of outpost or base there, then we'll need to be able to produce fuel locally. Methalox makes that possible. But there is also a small downside. Usually lunar landers use more stable propellants, and the spacecraft is fueled before it's loaded onto the rocket. But because Methalox requires cryo temperatures, that means it has to be loaded as close to launch as possible to prevent the fuel from boiling off. SpaceX actually had to modify its Falcon 9 rocket to allow the lander to be fueled at the same time as the rocket, about 2 hours before launch. It's a small thing, but it's yet another innovation to this whole process that I find really cool. Okay, so that is basically everything you need to know about the Intuitive Machines IM-1 lunar landing attempt coming up later this week. I'm sure there will be some sort of control room live stream from Nova Control in Houston, Texas, and as soon as a link is available, I'll make sure it's down below. Successful or not, this is a huge deal, and I'm really looking forward to seeing what this team accomplishes.